Alrighty, this is the third worksheet on our new exponential unit. And just like with our first worksheet, we went over how to find a function based on a growth rate. Now we're going to review how to find a function based on a y-intercept and a point. Again, this is the sort of thing where we are going to be reviewing, so I'll give it a decent once over. But if you want a more in-depth analysis on how to do this, check out some of the videos in the previous unit, Unit 2, and those will go into much, much farther detail than I will here, but I'll hopefully give you some decent pointers on where to start. Again, the last unit was preparation for this unit, so yeah, here we go. So starting out, we've got 0, 4, and 3, 108. If you have this kind of thing here, where the first number is going to be 0, where you have a point, and the first number is 0, then you basically have the y-intercept. Well, you do have the y-intercept. And if you have the y-intercept, then you have the initial value. So again, if you have the y-intercept, whether it's represented here as 0, 4, or the problem basically just says the y-intercept is, then you're dealing with the same initial value. And in this case, the initial value is going to be 4. So as with last time, I'm not even going to start with the general equation. I'm just going to write 4 times b to the x, because that's what we're solving for. There we go. I'll get it centered on camera. So now we have 4 times b to the x. We have this function here, but we have this point, and that's the only other piece of information we have with this. The only other piece of information that we have with this problem. So we've got to use it somehow. If you remember, when it comes to points and point coordinates, this is going to be our x value. This is going to be our y value. So if we had a graph, we would find x equals 3, and we would put a dot on y equals 108. And so what that means is if our equation, an equation is basically just a description of a line on a graph. And so we're trying to find the line on that graph, and we know that the line goes through these 2 points. So if we know that the equation, if we know that the line starts here, which it does because it gives us our initial value, and it goes through here, then we know that at some point y equals 108 and x equals 3. So what that also means is that we can feed these points in directly to this equation here. So that gives us 108 equals 4 times b, because that's what we're solving for, to the third power. All right, going to do a little bit of algebra here. That's going to cancel out. I want to make sure that I do everything on video, because apparently that was an issue during the last unit. 108 divided by 4 equals 27. Alrighty. So that gives me B3 equals 27. All right. I'm going to show you all. I really would have preferred if we did fractional exponents, but if that's not, I don't think that's an option anymore. So I'm just going to show you how to deal with something like this. If you have b raised to some power equals whatever number it is, it doesn't matter. It can be a fraction, it can be a decimal, doesn't matter. It can be a whole number, it's not important. What you're going to do is you're going to type in what b is. So what is the power that b has? What does it start with? In this case, it's going to be 3. So b to the third power, you type in 3 first. Next, you're going to hit second, and so that triggers secondary function on each of the buttons. And then the one you're going to be looking for is the up arrow that you usually use for exponents. So what that'll do is that'll give you this little symbol. So if you hit the right button, then you should see this symbol, and it should be 3, and then you have X followed by the little angle house thing here. Once you have that set up and you have those things appearing, then you're going to type in whatever b equals. You're going to type in this number here, whatever b equals, so 27. So a quick reality check. 3 should be here. The number that you want to that the other number should be here. And then x, and then you should have this little x thing here. what this function is called the x root of a particular number. In this case, we're trying to find the third root of 27. So what number times itself 3 times equals 27? So if you have a number b, b times b times b equals 27. You can either work through guess and check, or you can just plug it into the calculator like this, or you can use fractional exponents as I tried to do before, but that obviously didn't take. So here's how you do it using our loaner calculators, and how you would do it if you had more advanced calculators yourself. You have b raised to the third power, so that's where you put the 3, and then you put second and then a little up arrow, and that creates this little doohickey, and then you just type in the number that b to the third power equals. You should get 3. Yep, that gives you 3. So that means b equals 3. So your final function, f of x, is equal to 4 times 3 to the x. All right, we'll do these problems and we'll walk through, I'll go through them relatively slowly, but after that specific demonstration, we should, if you need to rewatch the demonstration, please do so. I'm going to go through just a little faster here. F of x equals 7 times b to the x. So again, if we have the initial value, that means that we have the a part of the exponential equation. We have another point here, 356, so that means that x has to equal 3. So x has to equal 3. F of x has to equal 56. Alrighty? So 56 equals 7 times b to the third power. Alrighty, we're still doing pretty well. Divide both sides by 7 to get rid of it on this side. 56 divided by 7 over here. And then that should give me age. Look, yeah, there we go. So h equals b to the third power. All right. Well, again, I'm just going to let the calculator do the lion's share of the work. I know that the answer is 2, but I'm just going to go ahead and use the calculator anyway. So I'm going to put the power that b equals first, which is 3. Then I'm going to hit the second function, and then the up arrow to make that little doohickey appear, the little x with the little triangle house thing. Now I'm going to hit the number that b to the third power equals, which is 8. Should give me 2. Yep. So b equals 2, and f of x equals 7 times 2 to the x. And that's going to be your final answer. Some of you may be asking, why didn't you just teach us how to do this with the calculator before? It is because in our math department, we were told to teach you all using fractional exponents until it basically became clear that they weren't going to take. So I'm more interested in you all doing better on the tests than you are in doing better on the tests the way that someone wants you to. I want you to do better on the tests, period, as opposed to doing better on the tests in terms that I want you to do. All right, so again, we've got 0, 5. So that means that we know our initial value. So we've got f of x equals 5 times b to the x. All right. Now what else do we have? Well, we've got 3. We've got 320. So this is the only other piece of information we have. So we'll just feed these in. F of x equals 320. X equals 3. So that gives us 320 equals 5 times b to the third power. All right. All I've done is I just put the values in for x and f of x that I've got track of. All right. As ever, I'm going to divide by 5, get rid of this, divide by 5, and that's going to give me that b3 equals, I'm doing this off camera, but 320 divided by 5 equals 64. Alrighty. I'm just writing that in ahead of time because I know I'm going to get the answer here. So again, I'm going to go through. So I've got b to the third power, so that means the first button I'm going to press is 3. Then second function, up arrow. I know it was off camera, but that's why I'm telling you what buttons I'm pushing. And then I put in 64 because 3 has to go here, and then this number has to go on the other side. Hit enter, and I get b equals 4. So my final equation is going to be f of x equals 5 times 4 to the x. There we go. Alrighty. Boy, we are just moving along. We're moving along here. So again, I've got a 0, 4, so that should tell me it's the y-intercept. And so because it's the y-intercept, this number is going to be my initial value. All right, we're off to the races. We're doing pretty well here. I'm going to substitute in all the different values. So 1 is my y value. That's going to go into f of x. And then 2 is my x value. So that's going to go in over here. All right. Now, you can tell already that we're going to be dealing with decimals. That's not a problem. That's not an issue. We are literally going to do exactly the same thing as we've done in the past. It's just the numbers are going to be slightly different, but it's going to be the exact same process as we've done with the other 3 problems. So I'm going to divide both sides by 4, deal with that, over 4. So that means I've got b squared equals 1 over 4. Alrighty, that's no problem. Because again, I'm letting this little fella do all the work. So I've got 2. I'm going to take b squared, so that number is 2. Then I'm going to do second up arrow. I get that weird little X house thing. Now I'm going to put in, because anytime you're using parentheses, anytime you're using fractions, just put in parentheses. It's the easiest way to make sure that you get the correct answer. So that will give me 0.5, which is also equal to 1/2 if you want to go that route. Either way, the final answer, the important thing to remember is that it doesn't matter what these numbers are. It doesn't matter it doesn't matter if they're greater than 0. It doesn't matter. Hang on, I'm trying to get the glare out. It doesn't matter if these numbers are greater than 0, less than 0. It doesn't matter if they're decimals. Doesn't matter if they're constants. You're going to treat them the exact same way. 2 is the first number you type in, then you get the little x root thing, and then you're going to put in the number that b squared equals as your next option, and then that answer is going to give you the final part that you need. So f of x equals 4 times 1/2 to the x, and there you go. So again, if you need to go over some of these, just rewind the video, and I'll yeah, just rewind the video. I'll be happy to go over them again. But again, at this point, this is what we spent most of Unit 2 going through, or at least a fair chunk of Unit 2 going through this. So these numbers should be, I mean, again, I'm not expecting you to do this in your head. I'm sure as heck not doing it in my head, but it shouldn't be new information. It shouldn't be, you shouldn't be seeing this for the very first time, is what I'm saying. So let's move on to the word problems. Alrighty. All right. So 5-year-old Joey dropped his ice cream cone on the sidewalk. The ice cream cone weighed 12 ounces. 2 hours later, only 4 ounces were left on the sidewalk. Write an exponential equation. I mean, I kind of wish they'd said write an exponential equation modeling the situation, because anyway. So we'll start out if we know. So I'm just going to do f of x. It looks like 2 hour. Looks like we're 2 hours later, so we're going to be tracking it in terms of hours. That's just something you want to keep in the back of your mind, because again, it doesn't really matter what time interval you're following when it comes to creating the exponential function. That matters when you're evaluating the exponential function. When it comes to writing it, what you're basically saying is, what you basically are more worried about is how much is left at the end of each, how much is left at the end of every hour, so to speak. And so it's not going to be, I put it there right in the middle. It's not going to be a straightforward path as it's going to start out with. So we're basically going to do here what we did up here. It's just that now we're getting this point in words as opposed to just getting an actual number for the point. So we have write an exponential function, f of x equals, so it's weighed 12 ounces when it weighed 12 ounces when you dropped it. So we know it's going to start at 12 times b to the x. So 2 hours later, only 4 ounces were left on the sidewalk. So in 2 hours, only 4 were left. But here's the thing: is that the time interval that we want to evaluate? Is that how we want to write the equation? So if it's so reading ahead, how many ounces are left after 6 hours? Okay, so we're looking at the passage of time. I mean, we're obviously looking at the passage of time, but the time interval we're looking at is hours. So what that means is we have to put this, whatever this exponential equation is, has to be in reference to hours. So thankfully, we have 2 hours later, 4 ounces were left. Okay, that looks like a point I can plug in. So if after so 4 ounces remain, starting with 12 after 2 hours. So again, after 2 hours, that's my x variable. I'm tracking hours. So x equals 2. Only 4 ounces were left. So what we have is 4. Started with 12. Now we've got 4 after 2 hours. We need to figure out what b is. So we're doing the exact same thing as we did up here. Okay, so I'm just going to divide both sides by 12. So now b squared equals 1 over 3. So b equals, I'm just in anticipate, so there we go. So we got b squared equals 1/3. All right, let the assistant do let our assistant do all the work here. As soon as I find, there we go, there's a good spot. I think I'd remember where the spot was after all this time. But anyway, we do first of all the exponent that's attached to the b. Then I'm going to do the second up arrow to get the little house with the x. Now, because it's a fraction, I'm going to use parentheses when I put in the 1 over 3. That's going to give me 0.577. I'm just going to say b equals 0.58. And you're going to get weird numbers like that every now and then. Just as long as you're consistent with the rounding, it really doesn't matter what you go for. So the exponential function at this point is going to be f of x equals 12, our initial value, 0.58 to the x. All right. So that's probably going to be the hardest part of these sorts of problems, is coming up with the equation. So how many ounces are left after 6 hours? Well, all right. 12 times 0.58 to the 6. Let's see how many are left after 12 hours. Hmm. That's not a lot. It's not a lot. Looks like 0.46 ounces. And just, yeah, that's what I did. 12 times 0.58 raised to the 6th power. Yep, 0.46 ounces. So yeah, so don't drop your ice cream. Yep. Now the ironic part is, the funny part is that the weight of the ice cream isn't going to change. This is probably just the weight of the frozen part of the ice cream, because the weight of the ice cream itself isn't going to change, because it's going to go from a frozen state to a liquid state. So how many ounces are left after 6 hours? It should still be 12 ounces. Um, so either they're measuring solid ice cream, or they're measuring how much has been picked up by dogs or birds or whatever, anymore. Or hopefully not humans, but there's some gross people out there. All right, next one. Population of New York City has increased from that in 2000 to that in 2020. All right. So again, we're starting out with f of x equals, and I'm going to treat this first one as an initial value. Again, when we're dealing with time and then make a prediction, what will the population be in 2025? So we have time. So again, we're referencing time. We're looking at years specifically. But when we're looking at years, we're looking at how many years have passed. What is the passage of the years? And so what that means is we're starting in 2000. So our initial time is going to be in 2000. And so time equals 0. This is going to be our number. This is going to be our number. So I'm just going to write all of these out, because something tells me that I'm going to need to. and then times b of x. So that's going to be our exponential function that we work with. But we need to get a point. Now we need to get a second point in order to do the whole set, in order to do the whole review the exponential equation using this. So we have the next one, 2020. We have 8.38 million in 2020. So what is the difference between 2000 and 2020 in terms of years? It's going to be 20 years. So in 20 years, we've got 8.38 million. So at time equals 0, we've got 8.009 million. At time equals 20, we have 8.38 million. So that means we've got this is going to get exhausting. Times b to the 20th. Wow, we're really gonna push the calculator on this one. So I'm not gonna write in the step where I divide it. I'm just going to assume that you all understand what I'm doing what I've done with the last couple of problems, and I'm dividing it and then rewriting it in terms of b. I'm not going to rewrite all that. So I've got b to the 20th equals, so that's 8380000 divided by 8009100. Okay, b to the 20th equals 1.046. Alrighty, this is the perfect. This is the perfect time to let the calculator do all the work. So again, I'm going to start out. I'm going to type in what the exponent is that b has, and hit second, and then the up arrow to get the little x house doohickey, and then 1.046, and then that's going to give me, that is, all right, 1.0023. All right, so write the exponential equation. I'm just going to write the exponential equation down here. F of t equals 8,009,100 times 1.0023 to the t. All right. So make a prediction. What will the population be in 2025? Well, again, in 2025, we're looking at the passage of time. And so 2025 is 25 years after our initial look. So we're going to set t equal to 25. Times 1.0023 to the 25th. Now you understand why, it's like, and here's the thing, if you learn how to do Microsoft Excel or Google Sheets or one of the variations of it, then these problems are almost trivially easy because of data entry and things like that. But while you have a calculator and pen and pencil, this is what you got to work with. Alrighty, let's go with, so that's equal to 804.825561. Okay, kind of crudely written there, but yeah, that's that'll be our answer for that one. Okay, so again, we're just using 2 points to find the exponential equation. There we go. To find the exponential equation, and then we're just plugging in the values. So this worksheet is just a different variation of how to find that exponential equation and then evaluate it. And we're not done yet. So let's move on to the next question. Let's see. All right. I kind of wish they'd given us more space for some of these, but all right. Mr. and Mrs. Boyce bought a house for $96,000 in 1995. Oh, that sounds so nice. And then 8 years later, they sold it for $115,000. Thanks. All right, so they bought a house for $96,000, so that means I'm going to say F of t equals 96,000 times b to the x. Times b to the t, my mistake. In 2003, they sold it for 115,000. So difference between 1995 and 2003, since we're looking at years, we're looking at the passage of time. So 95, 2003, I think it should be 8. Is 8, and then 115,000. So what I'm going to do is 115,000 equals 96,000. Again, I kind of wish they'd given me more space here. Times b to the 8. So hopefully you all understand that I'm dividing both sides by 96,000 in order to get this number. If you don't, I just told you what I did to get this number, so hopefully it's not too big of a surprise if you're following along. Oops, 6,000. 1.198. So b to the 8th power equals 1.198. Therefore, b equals, and here's the part I am going to do on camera just to kind of hammer home what the idea is. So we're starting out, we have b to the 8. So 8 is going to be the first number I put in. Then second up caret to get this little doohickey x root looking thing. Then I'm going to type in what b to the 8th equals, 1.198. And then that's going to give me b of 1.023. Yeah, I'll do that. Okay, so what I'm going to do, because again, they didn't give me a lot of space, so I'm just going to maximize the use that I have. It means f of t is going to be 96,000 times 1.023 to the t power. Alrighty. What could they sell their house for today? Oh, bugger. All right. So again, we're starting out 2025. We have to reference that it's 2025. Thankfully, it's a nice round number, so it's just going to be 30. So f of 30 equals 96,000 times 1.023 to the 30. This is why people can't afford houses today. Well, one of the reasons why. So 96,000 times 1.023 up arrow 30. Oofa. Let's see. 189,000. I'm just going to say 190,000. Yeah, they bought it for 96,000 in 1995, and then 30 years later, it's doubled in price. So yeah, thanks, Mr. and Mrs. Boyce. All right, moving on. In 2016, there were 200 million Pinterest users. In 2015, there were 148 million users. Oh, all right. So they shook up when they kind of shook up when they gave us the information. They're still giving us the same information of 2 points with the passage of time, but now they've kind of twisted around when they tell us that information. So good on you, good on you. I appreciate that they're writing the same problem over and over again, and so they have to find a different way of phrasing the same thing. So yeah, good on them. Good on them for A+ for effort. So in 2015, there were 148 million users. What that means is that our initial value, f of t, is going to equal 148 times v to the t. And so I'm just going to stick it in terms of millions because I've got 148 million, I've got 200 million. Something tells me that it's just going to be easier to do that than it is to write out all those zeros. So write out the exponential equation. Well, I can't do that yet. I still have to find out what b is, but thankfully, I have got a second point that I can use. So 2016, there were 200 million users. So 200 equals 1.48 times b. Now here's the fascinating part. Difference between 215 and 216 between 2015 and 2016 is just 1 year. And so what that means is b to the first power equals not 1.48, crying out loud, 148 times b. So I'm going to find out what b is just by dividing both sides by 148. I can certainly live with that. So 200 divided by 148, it gives me 1.35. All right. So I actually do have enough space to do this. Equals 148 times 1.35 to the t. All righty. So there we go. All right, make a prediction. How many users could we expect in 2030? All right, so in 2015, there were 148 million. With the passage of time, 2030, 2015, so that means that we're calculating this over 15 years. So how many years have passed between 2015 and 2030? Because each year that passes, this rate applies to this value. And so it's 1.35, year passes, 1.35, year passes. And so again, it doesn't matter what the years are labeled. What matters is how many years are passing by. So in this case, it's going to be 15. So that gives us F 15 equals 148, 8 times 1.35 to the 15. So I don't have to do anything too complicated, so I'm just going to do this off camera here. 148 times 1.35 up arrow 15, and that'll give us 13,343 million, which is technically 13.343 billion, but everything is in reference to millions, so that's what I'm going to stick with. Now, wait a minute, you try. Oh, well, thank goodness. I finally have an opportunity to test out my skills with this already. Whew, I was worried. Worried I'd have to go the entire video without seeing if I could do these problems. All right, so in 2007, the Census Bureau estimated the population of the U.S. to be 301 million. In 2020, the population was 330 million. So that looks to me like if I have 2007 as time equals 0, that I have an initial value of 301 times b to the t. And that also means that in 2020, I've got another data point at 330 million. But I can't use 2020 in the calculator because the calculator will just hate me. So what is the time difference between 2007 and 2020? It's going to be 13. So what that means is, just write it over here. So what that means is, so when 13 years passes, population is 330 million. It started with 301 million here, but in 2020, 13 years later, it's 330. So I'm going to rewrite that. 300. No, I can do this. 330 million equals 301 million times whatever b is, and we had a 13-year gap. All right. So I'm going to divide both sides by 301. I'm not going to write it down, but I'm just going to do it off camera. So, oops. So I got b to the 13, and I'm just going to divide both sides by 301. And yeah, I'm just going to divide both sides by 301, write down the answer, because you hopefully understand where some of these numbers are coming from by now. B to the 13 equals 1.096. All righty. So what does that mean? That means that B is going to be equal to, all right, so I'm feeding in 13, second up arrow, 1.096. So again, we're starting out B to the 13, then I hit the little second up arrow, and that gives me the little weird hash, the X thing, the X root thing here. And then I type in what B is equal to, 1096, 1.007. Alrighty. So write the exponential equation, no problem. It's 301 times 1.007 to the t. That gives us our f of it. That gives us our f of t. That gives us our exponential equation. All right, what will the population be in 2050? All right, so again, if we were looking at 2020 versus 2007 with the passage of time, we're going to do the same thing with 2050. In this case, however, the difference in time from 2007 to 2050, I think it's going to be 43 years. So what we're looking at is F 43 equals, yeah, we start out 301 times 1.007 to the 43rd power. And here's hoping the calculator doesn't break. Otherwise, I'm going to have to do some, I have to go to the fallout, and editor Richard's going to be really irritated. Ooh, alrighty. 4.629. Alrighty. So yeah, there we go. So yeah, that's how we take care of it. Yeah, all right. Well, thank goodness I was able to get that practice in. Now I'm going to try 3 more problems just to make sure that all the work that I make sure that I can definitely do these problems. So we'll start out from 2015 to 2018. Twitter went from having 205 million users to 330 million users. All right. So again, they're kind of shaking up how they present the information, but they're still presenting the information in like 2-point form. So in 2015, that's the first year that we're actually counting data. So that means that in year 0, we have 205 million users. So if that's what our value is at year 0, that means that we've got 205 times whatever the rate is to the time. Now we have our second point, which is 2018 and 330 million users. Well, again, when we're looking at years, we're not looking at the number of years. We're not looking at the year numbers per se. We're looking at the passage of time. So we're looking at how many years have passed. So in this case, 2018 minus 2015 is going to be 3 years. So after 3 years, we have 330 million. Well, that's a pretty good looking point to plug into our exponential equation so far. So let's see if we can solve for b for that one. So we've got 330 equals 205 times b to the 3rd power. So again, I'm going to divide both sides by 205 off camera just to kind of save myself some space on here. So 330 divided by 205. That's going to give me I'm going to say 1.61. And so with, I don't have to compress it down that much. So again, when I've got b raised to some weird power equals some number, no problem. I've got b to the 3rd, so I write down 3. Second up arrow gives me that little device. And then I'm going to type in 1.61, and that gives me 1.17. All right, 7. So what that means is our final equation is going to be f of t equals 205 times 1.17 to the t. All right, so that gives us our basic equation, our basic exponential equation. So make a prediction. If the trend continues, how many users will be there in 2025? So if we're looking at 2025, that means that the passage of time we're looking at is going to be 10 years. So the first one was 3 years, and that's what we used to get b. Now we're just going to evaluate this function at 10 years equals 205 times 0.17 to 10. So again, the way that I got 10 was the initial time was 215. That was what I did to get 205. And again, I'm just looking at this equation here. If I start at 2015, but I want to know what's in 2025, each year this value changes based on on how many years have changed, how many years have progressed. And so if at time equals 1, then we gain 17%. At time 0, we've got 205, which is how the formula was set up. And so we're looking again for the passage of time between 2015 and 2025, which is 10 years. So I'm going to just go through, I'm going to evaluate that off camera because it's a pretty, again, by now, if for the evaluations, whenever it says evaluate or we have to solve for it or we're going to use this, just type in what you see reading it from left to right, and you should get the same answer that I do. Up arrow 10. Okay. Oops. Pushed the wrong button. All right. I accidentally entered it incorrectly, so there we go. I'm going to say 985. So there we go. 985 million users after 10 years. Yeah, probably sounds about right. Anyway, next to last one, we've got in 2000, there were 20,000 entries on Wikipedia. In 2020, there were 6.5 million articles. And this time, they're synonymizing, they're synonymizing entries with articles, or what that means is that they are saying that entries and articles are the same thing. It's just a verbal trick, but anyway. So in 2000, there were 20,000 entries. So that tells me that my initial value is going to be 20,000. And then in 2020, there were 6.5 million. Alrighty. So, yeah, I'll say so. I'm trying to decide if I should convert this to a decimal or not, or if I should make this. Yeah, you know what? I think I am. I think I am. So I've got 6.5 equals, and then 20,000 with decimals is 0.0. Yeah, 0.02. Yeah, there we go. So 0.02, and the way I'll verify this, just to be 100%, 6.5 times 10 to the 6th is going to be 6.5 million. So that's 1, 2, 3, 4, 5, 6. So that's 6.5 million. And then 0.02 times 10 up arrow 6, which is the same which is the same number of zeros behind it, gives me 20,000. Okay. So yeah, so this works. This conversion from 20,000 to 0.02, and all I'm really doing here is I'm just doing a quick conversion to get rid of all these zeros. If you want to type in all the zeros and you want to keep writing them in, that's certainly your prerogative. You're not going to get a different answer than what I'm getting. Mine will just be in decimal form. Times b to the, and what's the passage of time here? We go from 2000 to 2020. 6.5 million, so that means that 20 years have passed. So again, I'm going to divide both sides by 0.02. That's going to give me b to the 20 equals, this one's going to be big, which is probably why I converted to decimals. 6.5 divided by 0.02. Oh, okay. Well, 325. So b equals, and this is the perfect time to use that root symbol. So 20, which is the exponent attached to b, second up arrow to give me that weird little thing, 325, which is the number that b is equal to. Oh, 1.33. Alrighty. So what that means is f of t equals 0.02 times 1.33 to the t. Okay, then how many can we expect in 2030? Well, if we got these figures by assuming that the passage of time was in years, so 6.5 is for 20 years, which is that. Then we just have to evaluate this function at time equals 30 because it's 2030 minus 2000. So that means we have f of 30 equals 0.02 times 1.33 to the 30. And I'm just going to, again, you can, as you just read it across going left to right and enter it in exactly as you read it. Ooh, wow. 103.89. Okay, so we have 103.59 million articles by 2030. Still 2025. I don't think we're near that yet, but they keep doing fundraisers, so that probably is delaying people from updating Wikipedia articles. Anyway, last question for the worksheet, and then we will move on to the next worksheet of word problems. Let's see. One bacterium sitting in a petri dish on a science lab. After 5 hours, there are 32 bacteria in a dish. So unlike in the previous worksheet where the population doubled every 6 hours, these are just going to increase at a steady rate, at a steady, consistent rate, apparently over 5 hours. So we've got one bacterium in a petri dish in a science lab, and then after 5 hours, there are 32. Well, the exponential equation is actually pretty easy to start out with. We have f of t. If one bacterium is sitting in the petri dish, that means that the initial value is 1. And if the initial value is 1, then that means that we can basically ignore it. And we're now solving for an equation that's just the rate itself, which is pretty awesome, really. So after 5 hours, there are 32 bacteria in the dish. All righty. So 32 equals b to the 5th. All right. So what I'm going to do is, so therefore, b equals, so I'm just going to go in and I'm going to re-enter that. I'm going to redo the same button presses that I did before. So b is going to equal 5. Second up arrow gives me the root x house thing equals 32. That's going to give me 2. So b equals 2. That being the case, equals 2 to the x. See, things are a lot neater and a lot nicer and a lot faster when your initial value is 1. But let's keep it going here. We've got make a prediction. How much bacteria will there be after 12 hours? Well, f of 12 equals 2 to the 12. Oh, and it's going to be a big number. 2 up here at 12. Oh, not as big as I thought. All right. 4096. Well, I mean, given that we started with 1 and after 12 hours we have over 4,000. I mean, that's a pretty good. That's pretty good. That's a pretty good growth rate. Anyway, oh, there we go. Now it's 100% correct. Anyway, like I said, a lot of these are just figuring out the passage of time, solving for rate, solving for b, figuring out the passage of time, and then just applying the equation that you solve for. So yeah, that does it for this one. Next one should be the assessment review before the first assessment.